LeetCode Problem number 152, maximum product subarray. So this problem gives us an integer array called nums, and our goal is to find a subarray that has the largest product and return the product itself. Here it just gives us the information that the answer will fit in a integer, right? So the way I chose to approach this is while adding up all the products in itself using a iterative method. Right, so I'm only looping through the array once. I'll be keeping track of the minimum number and the maximum number. Right. We'll show you why in a bit, but let's move on. The result is what we'll be using to return as the answer. So in this case, initializing result as the first number is 2, the current minimum as 2 as well, and so is the current maximum. Right. Right now we are only iterating through the first number, which is 2. So here I'm starting I at 1, skipping past the first number, and will become 3, right? So n is 3. 10 max here is what I'll be using to store the current max times n, because over here I'm replacing current max with the max, but in my current min I'll be using current max, the old current max as well, so I need to keep a temporary variable to store the product of current max times n. So 10 max is equals to 2 times 3, right? So current max 2 times the n, which is 3. This will give us 5. And here I'm calculating current max again. Right? So current max is equals to the maximum number of. Okay, here you can see I'm using two max functions, but since this maximum function is inside of another max function, so technically you can treat it as I'm finding the maximum number of 3 numbers, right? So I'm looking at 10 max of 5, current max, which was 2 times n, current minimum, which is 2 times n, and n itself, which is 3. This becomes 6. And from here, we know the maximum number of these 3 is 6. Same thing for current min, minimum of 10 max, which is 5. Current min was 2 times 3, and n itself, which is 3. So by having the product, we know that the minimum of these 3 products is 3 only, right? So basically the minimum is actually just taking the 3 without multiplying with 2 to get the subproduct, right? So a number itself can be considered as a subarray as well. After that, we update the result. In this case, the result will be the maximum of 2 with current max, which is 6, and we know 6 is bigger than 2. So we update result to now hold 6. Next, we iterate through, increment our I, and we move on to the next number. Right. Next number is -2. So here, I'm calculating 10 max again. Right. So 10 max is equals to the current max times n, -2. So this will give us -12. Right. Yeah. So this will give us -12 as our 10 max. Current max, I'll be recalculating it to maximum of -12. The current minimum times -2 with n itself, right? So this will give us -6, -12, and from here we know the maximum number from having included this subarray is actually just having -2 only, right? So that's what happens when we times -2 with this subarray, right? So the current max is 2, and here I'm calculating current min again. So current min is the minimum of 10 max, -12. Current min times n and n itself. So this will give us negative 6, 12, and 2, same thing. And now the current minimum we know is negative 12, right? Which is the product of these three numbers which form a subarray. Okay, so here the reason why we need to keep track of the current minimum is, let's say this were to be negative 4 instead, right? So by having current minimum multiplying with the next n, which is negative 4, we will get 48, right? Because negative times negative will get us a positive number. So this itself can be a subarray, which will give us a maximum product of 48, right? So that's why we need to keep track of the current minimum. But in this case, since it's a 4, not a negative 4, so unfortunately current minimum won't get to shine this for this case up, right? Either way, once we're done with all of this, our result will need to be checked. But since current max is negative 2 and 6 is more than negative 2, so we don't need to update result. Since that is done, we increment I to our last number, which is 4. Here we calculate time max again, which is negative 2 times 4. This will give us negative 8, right? So that's a product of multiplying negative 2 and 4. Here I recalculate current max, maximum of 10 max, current minimum times n, and n itself, right? So you can see here, if this were to be negative 4, 48 will be our maximum number, and result will be updated to current max, which is 48. But since this was a 4, so this will actually give us negative 48 instead. So from here, we know the maximum number is to just have the 4 itself. And for the current minimum, it's technically the same thing. For itself, current minimum will be negative 48, right? So we're waiting for the other negative number. But in this case, it does not come, right? It did not came in the end. Either way, 4 is less than the result we have, which is 6. So the current max product we have was from 2 times 3, right, which is 6. And that's what we'll be returning. And you can see over here, it checks out with our answer, right? So we have the product of 6. Okay, this is pretty straightforward. That's all I have to share. Thanks.